Thank you very much. I'm not really sure about the buzzwords, but certainly we're going to be covering maybe one or two. All right. So my name's Stephen Leedig. I'm a solutions architect with Amazon Web Services. I'm based out of Western Australia, but don't hold that against me. Here are some contact details. I'm quite active on both of those channels, and if you're interested in following up about this or anything else, please do get in touch with me. So, we're here to talk about the Monowhat. What is this Monowhat that I speak of? Well, as you've probably already guessed, this is really just a play on words around the monolith, right? And we've been hearing a lot about that. The Monowhat is the word that I get. It's typically when you're talking to customers, that's the kind of reaction you get when you tell them that they've got one of those in their data centers. They kind of go, Monowhat? And so when you go about describing this, you're kind of trying to conjure up images around what it is. How can I describe what this concept is? And typically, I'll reach into my visual vocabulary here and try and represent that visually. But on a more serious note, finding out what the definition for a monolith is actually a little bit more difficult than first thought. So it's actually not, as is typical in IT, there's never one single definition for a particular term or a particular concept. So the best one I found was from Wikipedia here. Where we're talking about monoliths, we're talking about single-tiered software applications in which the user interface and data access code are combined into a single program from a single platform, okay? And that's fine. And that seems like a reasonable definition of what a monolith is. But what interests me most is where do they all of a sudden come from? We've had this proliferation of this word monolith, and we're getting more and more organisations telling us that we need to break it apart with the architectural design pattern du jour, which is microservices. Okay. But I think what's missing is, and what we tend to do, get carried away with the technology implementations around how to achieve this migration to a microservices architecture. And what we really need is some more guidance around what's really at the heart of breaking up your monolith application in terms of what impact does it have on your architecture and what impact does it have on your teams and your organisational structure. So let's take a look at what monolith, kind of is and what it means. Now, I personally don't like the term monolith. I think it really conjures up some negative connotations around what we've really been trying to do, and that's over the last few years, and that's really develop applications around best practices and standards of the time, right? A few years ago, it was service orientation. Now it's microservices. And then it's going to be nano services, and there's this, the list goes on. And just because you've got a monolith or a traditional application in your data center, that doesn't necessarily mean it's been poorly designed. Our organisations put a lot of time and effort into making sure that we've got good architectural designs and code implementations. But one of the things that I guess we didn't take into account all these years ago was the fact that these applications that we've built were never built or designed to be distributed. And it's one of the challenges as we move to the cloud is that the distributed nature of cloud computing really challenges us to think of challenges us to think about how we build applications in totally different ways. And the applications that we have built have been by and large constrained around the resources that we've been able to that are available to us, right? There's certain constraints around the services and the products that we can use within our own traditional data centers. So, but that's not all bad, right? So there are some good things about monoliths. So at first, they're simple, they're not over-engineered. We can take advantage of in-process latencies, we've got a single code base, and they're pretty efficient when they're small in scale. But there are some cons as we move ahead, and here's just a bit of a list. But I think what I want to call out mainly here is that a monolith really has an impact on our ability to react to customer demand. Now, we've got some experience developing microservices at Amazon, But we didn't always have them. So at the turn of the century, we were building monolith applications around, and we had a monolithic team structure. It kind of looked like this. So we had a whole heap of developers working on the Amazon.com code base, which is fundamentally a single application, which is kind of multi-tiered, and we had a single delivery pipeline. So you can imagine as we sort of started to scale and the company started to grow, that this was a major impact on our ability to deliver change to our customers rapidly. What we've got now is this, what looks like a Death Star of microservices. And don't let this actually discourage you from moving to microservices. But the point here is that all of the services that we've built are kind of single purposes. They're connected through APIs, and fundamentally, we were doing microservices before microservices even became a thing. And so now our team structure looks a little bit like this. We've got thousands of teams developing services. Each have their own set of developers, and really built around this two-pizza team concept that you've probably heard a lot about. And so all of those services have their own delivery pipelines, and they've been designed and they've been purposely built to be able to interact with each other through common communication channels. And so that's allowed us to build up teams, thousands of teams, all around that microservices architectures. We've got continuous delivery. We're using multiple environments, multiple languages, multiple service combinations. Each team gets to make those decisions themselves. And this has allowed us to have over 60 million deployments every year. And this is a number from 2016. We're significantly more than that now. And that's really impressive. But what's actually helped us get to that is not necessarily just the technology, right? It's how we've changed our organisation, how we've aligned our teams in our organisational structure to actually support a microservices architecture. And this is a fundamental principle for you to be able to adopt microservices and adopt microservices successfully. So let's talk about microservices. Again, reaching into the definitions for what a microservices are on the internet, you've got to find many varied forms of definitions. So I'm going to read, so Martin Fowler's got a very good one. Microservice, architectural style, and that shouldn't be confused with an architecture. It's an architectural style that is a component of an overall architecture. Deploying a single application as a suite of small services, each running in its own process and communicating via lightweight mechanisms. This is a very good definition, albeit a very technical one. His colleague, or former colleague, Sam Newman, describes microservices as being independently deployable services that work together, modelled around a business domain. Again, there are technical elements to this definition, but what I like about it is that Sam is starting to introduce this whole concept around business domains. What microservices aren't, they're not defined by the number of lines of code you've got. Early on in the piece, there was a lot of discussion around, how many lines of code you should have in your microservices. It's not about that. Microservices that are just executing subroutine logic like calculations or validations, they're not services either. They're not microservices. They are functions, right? We've got a programming term for that. And services that only expose CRUD operations are just another way for you to expose RPC calls to a database. Don't confuse these with microservices. Just because you're implementing REST or SOAP interfaces for integration doesn't change the logical responsibility of what it is that you're trying to expose. So simply using a REST interface also doesn't make it a microservice. So bear these things in mind when you're thinking about the definition of a microservice. The best microservice definition that I think is the shortest and the sweetest is this one here from Udi Dahan. It talks about the technical authority for a business capability. This makes no assumptions around process, deployment, but puts the strong emphasis on the responsibility around a business domain or a business capability. So this is what we typically see in the architecture that surrounds microservices. You know, irrespective of what shape you make these things, you know, people will tell you need to have this service, you need to have that service, and you've got interconnecting lines. And that's fine, but the big problem is how do you get those boundaries, right? Simply, you know, coming up with a name and sticking it into a container doesn't make it a microservice. The hard work is defining what these boundaries are. They are fundamental to you building a successful microservices architecture. One way to help you define what those boundaries are is domain-driven design. Now, domain-driven design is a concept that was originally created by Eric Evans and publicised in his almost infamous book now, Domain-Driven Design. Vaughan Vernon also released a subsequent book about the subject. But fundamentally, what this book describes is a general pattern for you being able to talk about design principles and coming up with a technical vocabulary around design decisions. And fundamentally, it revolves around this whole concept of a ubiquitous language, which is really coming up with that technical vocabulary to talk to the business and to talk to developers who are building your applications. Now, if you're like me and you've read this book, you will have read the first part of this book and you will have learned all about value objects and repositories and entities and how to construct them, and also what the services are in the context of a DDD principle. And most people read that first part of the book and go, I know how to do it now. But the real value on this book is actually in the second part of the book, which starts around chapter 11, which talks about strategic design. So the first part is all about the tactical elements of implementing DDD. The second part is all about like taking that higher level view around what is it that I'm actually modeling, how am I modeling my domains, where are my boundaries. And so two concepts that I wanted to introduce, briefly talk about, is this concept around bounded contexts. So bounded contexts are that essential modeling tool for DDD and fundamental to microservices, and really help identify the boundaries around your understanding of the ubiquitous language and the concepts within your businesses and your organisations, right? And it's helping you to understand how to model entities and model those elements within your business that have fundamentally different meanings to different people. And so you get different models for these business concepts. And what do I mean by that? So a good example is out of Vaughan Vernon's book. He talks about this concept of a book, right? How do I model a book in the context of a publishing example? Now, when you first start off writing a book, you don't have an ISBN number or anything like that, right? You just have a concept. And as it moves through the phases of, contracting authors, managing editorial process, designing illustrations, etc., and marketing the book takes on new characteristics, and it starts to interact differently at various parts of the business. Now, it would be very difficult for us to just take what we would traditionally do when we approach an application problem and go, oh, we need this entity called book and we're going to model everything around it. We need to have multiple representations of the book depending on the context in which it's operating at a particular life cycle in this instance. And there are many such other examples that you might want to that you can draw from. I mean, having a policy in an insurance example is also one way, one of the things that has different characteristics, different meanings, different interactions, depending on which part of the business you're talking to. So to help us understand how multiple bounded contexts work together, we look at context maps. And these context maps really allow us to find out what are the relationships between our various bounded contexts and how do we start communicating between them. And the books talk about shared kernel patterns and anti-corruption layers. Some of these might already be familiar with you, and you might already be implementing some of these. But this is just taking that a little bit further in the context of DDD. One of the things that Eric doesn't talk about, and one of the things that I haven't seen organisations do a lot of, or not very successfully, is this understanding of modelling domain events. We are so busy modelling the entities and the relationships between our entities that we forget to model business events. And these are an essential part of creating a microservices architecture. And they're fundamentally about modelling things that have actually happened in your business, right? And they're very natural to us as human beings. When I've done something, I might let someone know that I've done it. I might not even care who that person is, but you know, at the end of the day, we're always reacting to events in a kind of response, in a responsive way. And these events are things that can't change, right? Once it's happened, it's done, they're immutable. And so when you're modelling these events in your systems, really should start thinking about, you know, modelling them in verbs that are in the past tense. And they should be really lightweight. They're not intended to be data transfer mechanisms, right? We're not meant to be publishing large amounts of data on our events. We want to find attributes that correlate between our bounded context to be able to communicate and provide lightweight mechanisms for defining relationships between them. And they're an essential modelling tool or essential component for a publish-subscribe design pattern. Which brings me on to coupling. Now, an essential part of software design is managing dependency. It doesn't matter if you're doing microservices or any other kind of application design, managing dependency is an essential part or essential goal for software development. And we've been taught that, you know, we want our applications to be loosely coupled and highly cohesive. And in the context, particularly in the context of microservices, we're looking at developing applications or services that have got a high degree of encapsulation. And there are different types of coupling. These are some of the more traditional forms of coupling, but there are others, more modern day ones. But when we're fundamentally talking about here is the things like afferent and efferent coupling, which when we're talking about application dependencies are really about the things that, the things that I depend on and and services or applications that depend on my implementation. We've got things like platform coupling as well. And these are fundamentally exhibited through things like proprietary protocols or components that are very platform specific. A big one is temporal coupling. This is one of the things that we really don't think about, or we actually sort of take into account when we're designing applications, and that's really dealing with time-based dependencies between collaborating system components, right? So when I'm executing something where I'm waiting for someone to do something, right? Now we've got asynchronous programming models, but this is not exactly what I'm kind of referring to. What we're really referring to is things that are kind of long-running, that can be done in total isolation. And one of the things that sort of the more modern day, microservice architectures that we see here is also around spatial coupling, right? Having to know where things are on the network, right? Those are elements that you need to consider when you're deploying microservices and looking at whether or not those services are autonomous in the sense that, do I need to know where things are on the network? But ultimately, there is no loose coupling, all right? So we're never going to be able to strive for loose or tight. It's not a binary kind of function. It's really, coupling is a function of multiple dimensions, right? Those things that I've just talked about, you need to make decisions and trade-offs around what's important to you and how you're going to be able to implement that. One of the ways that we deal with coupling is through messaging and messaging patterns. Now, Two services that I really want to highlight that are going to be crucial to a microservices implementation, irrespective of whether or not you're using containers or serverless, is Microsoft SQS and SNS. Now, SQS is a fully managed queuing system, right? It's our first service, it's our oldest service, provides huge amounts of scale, and is going to be a core component for decoupling your applications and providing a distributed microservices architecture. How do I create one? It's a simple API call, right? You don't have to implement any infrastructure. You get massive amount of scale, and it's as simple as creating a one-line command. One of the things that we recently released is SQS Event Source for Lambda. And this is fundamentally going to change the way that you think about a serverless microservices architecture. Right? We've taken away sort of the heavy lifting around integration and from an SQS perspective, and making that a first-class citizen. Now with Lambda is going to be polling the queues that you've used as an event source, and it's going to be detecting new message and invoking those and pulling those messages off the queue and passing that as a message to your Lambda functions. And you still got full control out of all of the capabilities that you would have with a traditional implementation, right? You can still do things like specifying visibility timeouts, having delayed queues, having derived policies, batch processing, right? All of those things you still have control over. But fundamentally, what Lambda's doing is providing you with a scalable way to poll those messages off the queue, and it'll increase or decrease the polling rate in line with your scaling requirements for your Lambda functions. Now, SNS, what is it? It's a fully managed publish-subscribe service. Now, it can do stuff like push notifications to mobile, but initially it was designed to deliver infrastructure-type publish-subscribe messaging. And this is going to be a core component for helping you deliver and helping you expose your domain events that you've modeled in your bounded contexts. And it's going to help you drive and deliver an event-driven architecture. And how do I create one? Again, it's as simple as invoking a simple command line with a few parameters. What it's going to be able to do is help you build this publish-subscribe mechanism. So basically, you'll have a single logical publisher, and as the pattern sort of defines, is that you don't really care who's listening. What you're allowing your other services to do is to be able to react to those events in their own different ways. And you can then define how those messages are invoked in the context of the service that's consuming those. Now, one of the ways that many companies have been utilizing SNS is through having a logical mapping between the event that they're emitting and the topic that they've created. Now, in this example, I've got a publisher publishing grey and blue messages, and those messages go to the respective queues. Now, and this is absolutely fine, but one of the things, I guess, from a coupling perspective that we need to be aware of in this type of architecture is having a look at the publisher. And the publisher needs to know where to send each type of message. Now, one of the features that we've introduced recently for SNS is this whole idea of this whole concept of message filters. And now in this kind of scenario, all the publisher needs to do is set some attributes on the message, and then the subscribers can subscribe and define the messages that they are interested in receiving based on the attributes that those messages have attached. So we've minimized the infrastructure footprint for this service, and we've put the actual logical distribution of those messages onto the message itself. And so now my consuming services can now provide a filter policy on the attributes that they're interested in receiving. And this really simplifies, removes some of the additional coupling that you've got in your publishers, as well as lowering some of your infrastructure costs. Now, the attributes that you can have just string attributes, or we've extended this to include exact matching, so you can have whitelist attributes, you can have prefix filtering as well, or as well as blacklisting. And we've also introduced this concept of numeric matching and matching on ranges. So you've got a lot of flexibility in the way that you set your policies. And it's really going to help you develop a sophisticated publish-subscribe architecture that's going to drive your microservices implementation. So one of the things that we also need to be aware of when we're developing our microservices is a long-running process. Every application will have one or more, all right? In fact, if you really think about it, a long-running process is very subjective. It can be a millisecond, or it can be hours, or months, or days. It really depends on your business domain. One of the things that people have been doing in a Lambda implementation, in a serverless implementation, is this whole concept of function chaining. Function chaining is fundamentally a poor design because really what we're saying here is that each function needs to know how to call the next function and needs to know how to call the next function. There's no way to any state transitions that you need to make because of the stateless nature of Lambda, you have to implement yourself. And so you're putting all of this coordination and all this logic into your functions that are fundamentally violating things like single responsibility principles. When really all you want to do is things like this. I want to retry failed states. I want to execute certain functions or processes in a sequential manner. I want to be able to do catch, try, and retry functionality, or I might want to execute things in parallel. Now, in order to do that, we've got AWS Step Functions. And this makes it really easy to coordinate these distributed services and do so in a very visual way. What that looks like is a little bit like this. So it's a specification. It's been open sourced and is fully available. You can come and see me later at the Dev Lounge to find out more information about that. In fact, we're creating we have a live demo a little bit later in the day. But basically, it provides you with a mechanism to coordinate all of your serverless applications or serverless functions in the context of a business, in the context of a bounded context, and allows you to do so visually. It helps you take that orchestration of execution out of your code, so your functions can be very focused around the activities that they need to perform. And it also helps you deal with state. So we manage the state transition for the lifetime of the execution of that workflow. And this is really going to help you simplify and provide that aggregate type of functionality that you'll need within your respective serverless applications. Now, one of the things that also helps us do is work with distributed applications or distributed transactions. Now, distributed transactions are things that have kind of been dealt with, can be dealt with a design pattern called Sagas. So this is really a pattern that was developed by Garcia Molina and Salem back in 1987. So it's been around for a while. In the early days, back then they recognised that there was a problem with dealing with long-lived transaction, particularly where there's no distributed transaction coordinator. And no cloud provider will actually provide you with one of those. So how do you deal with transactions that are distributed across multiple services or processes and do so in a way that leaves your application in a consistent state? So again, we're looking at temporal type of coupling and how do we deal with that. But fundamentally what we're doing is we're trying to provide a compensating transaction for every transaction that we've executed. And in the event of the failure, we're looking to roll back. Now, there's a very good example and a bit of a write-up about this on this particular website. And this is really this is an example of booking a holiday, right? There are certain transactions that we want to execute. We want to be able to book a hotel. We want to book a flight. We want to be able to rent a car. All of these things need to succeed or they fail, right? We can't book a holiday if one of these things fails. And this step functions helps us to coordinate the various transactions and interactions that we're having with potentially different systems. And so we're looking at pulling all of this stuff together. We can start to execute some really sophisticated microservices that can help us implement these patterns. One way, durable request response implementations. Return address, which allows us to define different targets for the messages that we've sent to our consuming applications. And publish subscribe, which I've already talked to you about. So some final thoughts around microservices. Don't forget the UI, okay? If we're talking about microservices as being the technical authority for a business capability, then that must extend to the user interface as well, okay? Look at leveraging composite user interfaces to help you align your services implementation with your user interface and provide a mechanism for you to be able to bring all those things together. So, in closing, chances are you're probably not going to need microservices. If you've already got a well-defined domain within your applications, then the time and effort and the complexity in pulling that apart is probably going to be a little bit overkill. You might want to decouple elements of your architecture, but maybe moving to a full-blown microservices isn't necessary. If you're going to go down a microservices strategy, then model your services around your business capabilities, okay? And spend some time diving into the domain. And consider a monolithic first approach as well, right? You are in a much better position to define what your service boundaries look like once you've got a well-defined application. If you've got a greenfield application, you're not going to get the benefits of microservices if you don't know what your microservices, what your bounded contexts are going to look like. And don't use a big bang approach, right? This is going to be, just like Amazon, this is going to be an evolutionary journey that's going to take time. And modeling your and adopting organizational structures and team structures that help support your microservices strategy is also a critical part, so don't forget that. And look at and leverage messaging services in your applications. You aren't going to successfully decouple anything without them. So with that, I thank you very much. Enjoy the rest of your summit, and I'm available at the Dev Lounge all day. We're going to be running a whole heap of demos. If you want to get into some of this stuff with step functions, please come and see us. Happy to talk to you more about microservices as well. Thank you very much.